Ladies and gentlemen, this is Joe's Classic Video Games back with another cool pinball repair video for you this evening. We have been working on this Mary Shelley's Frankenstein pinball machine just in time for Halloween this year. So we're trying to get this thing back together. We bought this from a gentleman who took it all apart and then sold it to me in a million pieces and wants me to put it all back together again. And we thought it was kind of interesting that that's what the book is about, putting the creature together. So we're trying to put the pinball together. So if you didn't see our first video, we kind of looked over what we had with the machine. We don't even know if we've got all the parts. And we worked on the transformer in the bottom that had been hacked up a little bit. And we got it where the transformer is sending out the correct voltages. And we've even got the little light bulbs working. There weren't any on the playfield because he removed most of the stuff from the playfield. But we put a couple in there just to test it. So the transformer we know is working properly now, and next thing up, whenever you're working on one, if you're trying to bring it back from the dead, is the power supply board. So the transformer we don't have plugged in right now because I wanted to check the voltages first, but they come up here to this power supply next. So we're going to remove this power supply board and work on it. So we're going to replace some capacitors, reflow some solder, just check out some things on it and make sure everything's all right. We're going to put it back in the machine and then check the voltages coming out of it. Once we're sure that all of that's fine, we'll allow it to provide power to the boards and we'll see if any of this thing works. The gentleman, it's an import from Belgium, but I think he lived overseas whenever he bought it and he brought it back to the United States. Like I said, he's removed about everything on the playfield. So our whole video series here is about trying to resurrect Frankenstein. So first thing we need to do is remove this power supply board and then put it on the bench, and we'll see what we can do to maybe hopefully get it working for another 35 years. 30 years. So it is very common on these power supplies for this connector up here to burn up. This is the general illumination. And they have repaired it by creating a little connection here that's just not how I would do it. So I have to remove the board. We're doing that anyway, and then loosen these two screws in the side so I can get these wires out of the cabinet. Then we'll repair this connector, repair this connector, and that will fix that problem. So that's our first issue. All right, so there is that part. And by the way, if you watch the previous video where we did the transformer, once you get past the transformer, all of these parts are the same and run off the same voltages. That's the whole purpose of the transformer. It takes the wall voltage and then transforms it into the voltages that the power supply and that the game needs. So once it runs through that transformer, it doesn't matter what the primary side is, 115 or 230 or whatever voltage you're running it off of. The secondary side will have the same voltages in any country. Okay, so this power supply would be the same in Europe as it would be in the United States. And so here's that connector we were just talking about. They have bent the pins a little bit to put that little connector thing on there. You can bend these back if it's not too bad, or you can replace that connector. They're easy to find, right? I think I can just bend it back. The connector that plugs into it we will have to replace though. Another thing that you need to always do on these in particular is this capacitor, and these capacitors definitely have to be replaced. If they get problems, you run into all kinds of issues with the game rebooting and the 5 volts not being high enough and all kinds of stuff. So it's a common thing. What happens is they start leaking too, so it'll mess up the board. So let me work on that connector a little bit, and then let me see about swapping these caps out. Okay, so one thing I like doing is resoldering all of the connectors on the edge. Some people actually replace the connectors. You can do that too. I usually just resolder them and clean the pins. Basically what happens is you get bad solder joints on the end of each connector, where whenever you pull the plug off, usually you pull one end more and then the other end bends the pins, and as they bend you eventually get it breaking loose from the solder joint. Now I didn't see any that had already done that, on this board, but it's a really common thing. So I clean the pins off with a little wire brush. Basically, you're getting dust and dirt off of it so that the solder sticks well. And then I just add a little bit of solder to each pin to make it real reflow. So that's what I usually do on the bottom of the board. So now about those capacitors. So the very first cap that we're doing is a 330, and the original one is a 16 volt. 330 microfarad, 16 volt. Now if you look at the bottom of the cap, you'll see the problem. It's letting juice leak out, and it's just eating stuff up. So that's got to go. So this causes all kinds of problems that, you know, on your, I believe it's the 5 volt line. Let's look in the schematics and see what exactly that cap does, and maybe it'll help us understand what problem you get if that starts leaking like that. So here in the manual it shows the schematic, and that 330 microfarad capacitor is right there. Notice it says it's a 25, but the one that was installed was a 16 and it was factory. And the reason that they can get away with a 16 is because it's just filtering the 5 volt. But since it's right there on the output of the 5 volt, it can just give you all kinds of problems if that thing is faulty. So we've swapped that one. Let's move back to our next one, which I guess would be C3. C3 looks suspect. Also C2. So what they are doing is they're in line with this bridge rectifier. It doesn't really tell us what voltage is coming in there, but it runs this little chip that basically regulates the 5 volts out. So C3 and C2 are also very critical. So here is C3, and it had not begun to leak yet, at least not to the level that you can see it. So no problems there. So here is C2. I don't know that it's actually leaking. Part of that was just it's like oxidation on the solder pads on the top of the board. Right. But of course I would replace this one and the previous one. We're swapping them out. So hopefully just replacing those will get our 5 volt nice and solid. Alright, so it replaced C1. It also looked fine underneath. So the only one that really looked bad was this one. But all of those have been swapped. These 4 big ones here are for the 12 volt unregulated. I haven't ever seen really a problem with those, but same thing, you can replace them if you'd like. I'm going to get this one though, C8, and I'm also going to get these 2 little ones, C15 and C14, because it's easy and they're cheap and I've got them. Okay, so we've replaced every capacitor except for these 4. And then on these Data East power supplies, you see this all the time. Look what's happened here. The fuse clips have broken. See how loose the fuse is? Now you saw I just pulled this right out of the game. They just deteriorate and break. And it's not just one, it's multiples. Right, see this end's done it too. And that one's done it. Sometimes you get lucky. Nope, that one's bad. Sometimes you get lucky. Nope, that one's bad. So I got to replace every fuse clip in the game. I mean, on this power board. Hopefully not in every one in the game. But all of these at least. Let's see these up here. Yeah, they're fine. But for whatever reason, this just happens. So you got to replace those. Now I've got some. You can order these online. Let me see if I can find them here. Pardon me. So you can order new ones. But it's kind of a pain swapping them because they're soldered in there pretty good. But we'll see if we can get them all out and get nice shiny new ones in there that'll hold the fuses right. Okay, folks, so all new fuse holders, and I like soldering on the top and the bottom because the traces are on the top, so you need to make sure it's making good contact. There's a lot of juice running through there. These, for whatever reason, were fine. I think on the last one I did, those were fine too, so I don't understand why one and not the but whatever. We did the caps, reflowed all the connectors,
So we're ready to put it back in the machine. And what I want to do is provide the input voltages to it, but then check the output voltages just to make sure that the power supply is doing what it's supposed to do. We'll use the schematics to check it. And then if that's good, we can try to boot up some of the boards in the game. All right, so I've plugged the transformer back in on the bottom of the cabinet. And then I've reinstalled the power supply, but the only thing I hooked up was the input voltages, which is on connector 1 there. All the other ones I have disconnected. And I've got my logic probe, not my logic probe, my probes for my voltmeter on ground and 5. So we're going to see what we get. Now when you first turn it on, we've got everything coming out of the power supply unplugged, but I think there's still voltages from the transformer going up to maybe the soundboard and maybe this solenoid driver board. I don't know that for sure, but so whenever you turn it on, you might get some coils locking on or something. So if it does, I'm going to turn it right back off. No, seems fine. So I can hear the transformer. Now we don't have the lights on because I unplugged the connections on the power supply to everything, including the GI. So it's telling us 5.05 volts on the 5 volts. That's good. So I'll carefully move over to the plus 12 unregulated. It's at 16. Now keep in mind it's unregulated, so. And then the minus 12 unregulated is minus 16. And then I don't know how easy it is to catch another voltage. Let's see. So we've got our plus and our minus and our plus 5 unregulated. General illumination, we know it's right. That's the input for the general illumination. This is the input for the 5 volt area. There is a 34 volt DC voltage for the solenoids. Looks like we can check that on fuse F5. One side of F5 looks like connects to that. And then this voltage for the lamps just goes through a fuse, and it's the, oh no, wait a minute, that's the, I think that's going through a bridge rectifier somewhere in the cabinet of the game. Okay, so on fuse F5 we should have 34 volts, and on fuse F4 we should have 18 volts. F6 it doesn't say. Whoa. Now if I can read which fuse is which. F6, F5, F4. F4. Now see, here's where it comes in. Yeah, that's not right. Apparently it does not work like that. Or I don't have that hooked up. Connector 1, pin 2 coming in, it runs through there. Yeah, we should have 34 volts DC on fuse F5. I wonder if it uses a separate ground. That might be the whole problem. Yeah, we're not getting that voltage there. Well, let me see if I can figure that out. There may be a separate ground for those voltages. Okay, so it doesn't seem we have the solenoid voltage getting onto the board or the lamp driver, the lamp voltage, but those run through bridge rectifiers that are mounted in the back. So it could just be that there's a problem there, which is this area here. You've got these 3 bridge rectifiers. So I think we're going to skip that for now. We're going to plug this up and see if we get our 5 volts going over to the main board and see if we can get anything to boot up.
I think we're ready to at least attempt it. So we'll give that a try and carefully boot it up and see if we get any kind of action out of it. And then with everything plugged up, if we don't have, we can track down these bridge rectifiers and see if they have the right voltage going in and the right voltage going out. Now, if the door isn't closed, it causes a problem where you don't have the voltage, at least to the solenoids, but the door's closed. So, but we can check all that here in a minute. But let's go ahead. I'm going to turn it off and plug all this in, and then we'll see if anything will boot up when we turn it on. All right, I plugged everything in. I didn't fix that general illumination connector yet, but I plugged in the part that was still there. Those two lines aren't plugged in, so a lot of the lights aren't going to work, the general illumination lights, if it comes on. So I'm going to turn it on. If we get anything locking on, like a solenoid or something, I'm going to turn it right back off. And we're looking for smoke. That's pretty cool. It says, open the coin door. All right. So the display is jumping around. That must have something to do with the driver to that or something. Or the voltage running to it. That looks pretty decent. So we definitely got some problems going on with that. We've got some of the lamps on the playfield working, which we must have our 18 volts back that we were looking for. The display looks like it's working, but it from time to time it gives you some weird jumping things, so we'll figure that out. So very cool. Sega. Yeah, I don't like how it's jumping. Okay, I'm gonna turn it off. I think the first thing I'll do is we'll go ahead and fix that connector on the power supply that I'm talking about for the general illumination. So here's the connector we're starting with, and I've done several of these, so I know that basically the wire colors go in order. It doesn't really matter because the top four connect to one side of the AC and the bottom four connect to the other side. So it's brown, yellow, green, purple, then there's the key, and then it should be brown, yellow, and then green, purple. This is the little connector that they added on. So we need a 9-pin connector to connect to the original spot there. All right, so one wire at a time, I cut off the connector, used a pair of crimps to crimp new pins on it. This is the part number you need if you're looking for these. And put a nice new 9-pin connector on there. And now that is fixed. So we'll turn it on just to make sure it looks like the lights come on. I guess we can't really tell because I've only got 2 light bulbs in the playfield, but they should come on. Alright, so see how the DMD is jumping and doing crazy stuff? Don't really like that, so let me see if I can figure out why it's doing that. Alright, so I turned on the machine and put it in display test in the diagnostics and had it running through the test. And as I was doing that, I could smell something. It's this unmistakable smell of like leaking capacitors. And remember, we just did this power supply. It's this. It's a smell like once you smelled it, you'll get it. But it's this kind of chemical smell of leaking capacitors burning, right? I don't see anything on the power supply that's bulging or looks bad. You've got these 2 down here, but they don't usually do that. You've got one here. And then you've got a whole bunch of caps over on the soundboard, but they all look fine. And then we've got the display. The display is what's acting up. And if you look on the back of the display, there are several caps down in there. Looks like they're surface mount. Maybe they're through hole, I don't know, but I'm going to guess that's what I was smelling. And that could be our problem with the display doing what it's doing. So what it's doing is if there's not very much on the display, it jumps around.
if the most of the display is full, it looks fine. But I'm thinking those caps. I don't want to turn it back on because of that smell that I'm getting. So I think what I might do is go ahead and pull this out and look on the schematics and figure out what's going on there. I think they're taking a normal voltage from the power supply or the transformer and stepping it up to make the high voltage that the display needs. If you're not like big into dot matrix display pinball machines, this is one of 4 games that has this large DMD on it. Most of them are about half this size. So Sega did 4 games. It was this one, Waterworld. Is it Waterworld? This one, Maverick, Batman Forever, and the other one may be Waterworld. There were just 4 games that they used this huge display on. I'd like to save it and get it to work with the original display, but if worst case, we can put a replacement deal in it. I tried reseating the ribbon cables already. No dice. So I'd kind of like to see what those caps are looking like. Okay, so I have removed the display and turned the game back on. I do not smell the unmistakable smell that I'm smelling. Okay? So I don't think it's anything that's still in the machine. It makes sense to me that it was the display. And you saw the display jumping. It's having some kind of problem. Okay? So I have removed the display. I took the this controller board off of it, and then this plate off of it, and we're down to the actual display. Now this is a pretty unique one. Like I said, it's only in 4 games, and it has this board that's basically part of the display. The actual glass is connected to this board at all of these little connections. So your problem is you can maybe cut this loose and bend this up, but if you break one of those connections, you'll lose that column on the display. And I don't want to do that. So on the back of this board, you've got several chips, tons of resistors and capacitors, but you've got these electrolytic capacitors. There's some kind of power supply here where the power comes in, and then this transformer steps it up to like 100 volts or whatever it needs to run. And if you look, sure enough, this cap has leaked all over everything. Okay, so Z, it says Z1. Z usually means a diode. So maybe that's a Zener diode or something. And then C33 is the capacitor. But we can't get to the bottom of the board. But we might be able to cut it off the top of the board and then solder it on this part of the board and do a bodge repair, right? So then this one, if you look, it's not looking great either. Looks like that's starting to leak to me. C25. Same here. You see the sheen difference on the thing there? That's all these caps leaking. So that is our job, trying to fix that. I think if we're able to replace these capacitors right here, that may fix our issue. But if we can't fix them, it's going to destroy the display, and you can't cheaply get another one. So this is either we fix it or it's a $300 or $400 bill. So let's see what we can do. I kind of want to see if that ribbon cable is only on this end or if it's also on this end under all these resistors somehow. Yeah, it's under this end as well. So I don't know how I can show you. See that? That's a ribbon cable connecting to the glass. And then there's also one all along the top. So what that means is you can't simply take this board and fold it this way and leave the glass under it. It's attached here and it's attached here. So you can't get to the bottom side of this board. If you even attempt it, you're just going to rip one of those connections and your display's done. So we're going to have to, like I said, try to do it from the top. Let's look in the schematics and just see, for instance, what C33 does. C33 and Z1, what are they involved in? It looks like it's some kind of power supply setup. My thinking is when there's a bunch of stuff on the screen, it must use a certain voltage, and everything looks steady when it's doing that. When there's not a lot on the screen, maybe that raises the voltage or lowers the voltage or whatever, and that's when you're getting problems with things jumping and stuff. And then I smelled that smell, which, you know, is probably the display about to burn up. We got it out, and now we see all this leaking. So definitely it has to be serviced. No way around it. Well, this is pretty fascinating. So there's different displays. There's 3 different ones. There's the one made by Dell, the one made by Vishay, and the one made by Cherry. The one we have is the one made by Cherry. And so I am not an engineer, obviously. But it looks like the way it's working is some voltages come in here. These are the 4 larger filter caps, which are 4700 microfarad capacitors. And then it runs into this little bad boy, a UC 3527. And eventually, that voltage ends up to that transformer, right? Now the voltage, it looks like, is 12 volts. Running into the transformer. Right? So we're looking for that cap. So we're looking for C33. That's the one that's leaking really bad. And this is it here. Okay. That cap is across a line that it's calling VRW, which is kind of like rho, right? Maybe voltage rho. And then VSN. I don't know what that stands for. Right? So that's the cap that's really bad. There's the Z1, the Zener diode apparently. That says 15 volt. Maybe that's a 15 volt Zener diode that looked like it was having problems too. And so it's VSN, and VRW. This is the area that's affected. Okay, now if you look over here, that's off one part of the transformer. So this is the primary of the transformer, this is the secondary of the transformer. So it creates that. Another thing that it creates at this part of the transformer is VSP, or that may be YSP. This schematic is very small. I'm just going to go with V, so VSP. So there's a VSP voltage that is creating. There's a VRW and a VSN. Okay, so here's VSP down here again, being filtered, I guess, by some of those other caps. Okay, so the problem that we know we're having is with VRW, which kind of seems like voltage rho, and VSN. And if you think about it, the issue that we're seeing is it's not left and right, which would be the columns. So the columns are up and down, and the rows are left and right. So we're having a problem where the text is doubled. It's on the wrong row. Now, I don't know if that makes sense, but in my head it makes sense that we've got some kind of problem with the voltage for the rows. The reason I'm thinking it's a voltage thing, like I said, is because if everything's on the screen, everything looks fine. If there's not a lot on the screen, you have problems where the stuff's in the wrong spot, the wrong row, or it's doubled, it's in 2 sets of rows. You know what I mean? So it seems like there's some kind of problem with the rows because it's moving up and down. You don't have a problem where it's repeating left and right. You have a problem where it's repeating up and down. So there's some kind of problem with a row, right? And we see that one really bad cap, and I can smell something that's, to me, smells like a leaking cap burning, right? And that one that's really bad is right there on VRW and VSN, okay? So if you look at the rest of the schematic, there are more columns than there are rows. So this represents all of the column connections to the glass, and this represents all the row connections to the glass. Okay? So if you look at the columns up here, they are literally showing you how it connects to the glass. Right? So here's the connection to the glass for all of the columns. And then here's the resistors. Again, the schematic is not great. There's probably a better one if I look around. But that's how it connects all the columns. And it has these 3 chips that connect to the columns. In my opinion, these 3 chips must work because we're seeing everything there. Whenever you have problems where something works and then it doesn't work and it's back and forth, a lot of times that's a bad connection or it's a capacitor problem, because capacitors change their value depending on what's going on. So as they warm up, they change their value. As they get old, they'll have a different value when you turn it on than when it's been running for a little bit and has some juice running through it. If they're leaking, it'll change the value. There's just, capacitors are a variable. So since I'm seeing things that are fine and then they're not fine and things move around, bad connection or power problem, right? So if you look at these 3 chips that run the columns, you've got all the connections. And you have VSP. And it's on all 3 of them. There's a 5-volt connection and VSP. 5-volt VSP. Well, VSP is right there. All right. So if you look here, you have the connection to all of the rows. And like I said, there's not as many of them because the display is wider than it is tall. I think it's 128 by 64. Is that right? So here is the connection to the rows, connection to the actual glass, and it's showing you what pin of the glass it's connected to. Let's see, does it say 68? 64. So there are 64 rows. And just for completion's sake, let's see what they say on the columns. I guess it's on that end. Maybe. It looks like it repeats. So it looks like that's 64 and that's 64 and maybe that's 64. 1 through 10, 20, 30, 40. There's 50. It's so hard to read. Yeah, 64 repeats 3 times. So what's that? 180, 192. So 192 by 64. Okay. So here's all the rows, and we think we're having a problem with the row where this one is doubled up to here, or instead of being here, it's here, or things are jumping around. So here are the 2 chips that drive the rows. And if you look, they are driven by VSN, VRow, and VSN. This VRow, I'm wondering if that's not VRW, and they're just spelling it different over there. No, see that? I guess that's it. VRow. Yeah, that says voltage out. Voltage in, voltage out. And this VSN is all over the place on this part of it. Oh yeah. So okay. So there's the voltage in to this chip that's creating the voltage row voltage, whatever that is. And then it's got this VSN connected to ground and blah blah blah. Well, this voltage in, you see it wraps around and it connects to this cap. So you're shorting the VSN to the voltage row if that cap's screwing up, or there's not the connection that it needs, whatever. That cap is messed up. So we got a problem with VSN and VRW, which in turn creates VROW. So that's just me thinking. It looks like if there was a problem with that cap, it would screw all this up, and then that would screw up your rows. I looked online, and there's been a bunch of people asking about theirs jumping like this, and nobody seems to have figured it out. But I also didn't see anybody say that they had successfully capped it. So I think what we might do is try to replace those caps one at a time, and see what happens. Now, if we pull that cap off the top, what's going to happen is the traces where the cap goes are going to be all screwed up. But that doesn't matter, because we could simply, instead of connecting that cap there, we could connect it to pin 1 and pin 2 of this 5-pin connector here, which I guess is P2, or it's actually more 6, 7, 8, and a key. So P2, it looked to me like wasn't populated. We could just put that cap instead of there, just connect it to pin 1 and 2 of the connector, and it would do the exact same thing. So there's the P2 connector, right? Pin 1 and pin 2, you see they have all the problems where this is leaked. So if we can get rid of this and then clean this up as best we can, and then put the cap back right there, which will be easier to solder to, it should be a way to replace that. Now the other ones need replaced too, but that's the critical one. So it'd be interesting to see if we only do that one, does it fix our problem? The Zener diode may still be alright. If it's not, it's connected the same way, so you could also connect it to 1 and 2, and that's if you pull this off and the traces are screwed up. So that's our challenge. We'll try one cap at a time and see if we get one to fix it. Alright, so I removed the capacitor, and I just basically scraped the board to clean it up as good as I could where the capacitor was, here as well. And then instead of trying to put it back on the pads, I just put it at where we were talking about, on the 2 pins here. Okay, when I messed with it, it just popped right off. I mean, just literally fell off by touching it a little bit. It's a 33 microfarad, 35 volt. Okay, there's another one right here that looks suspect as heck, right? Same thing, just barely touched it, it fell apart. So what I'm doing is, this one is on the same line, ironically. So I have again just scraped the heck out of the pads. Now remember, we can't get to the back of this. So I've just scraped them as well as possible. Hopefully there's not a lot of corrosion on the other side. And it's kind of revealed the 2 pads, but what's going to happen is whenever I try to add solder to that, it's probably just going to make a big mess, and I won't be able to get solder to stick. Also, since it's such a tight design, if the solder where I've scratched it, see if I can get my thing in there. So like this is the little pad, but it's real close to this ground here, and so where I've scratched it, it would be real easy when you put solder on there for it to join the 2 and make a short. Same thing here. That's the little pad, but it'd be really easy to short it from there to there. So I'm trying not to do that. So looking in the schematics, it looks like a couple of these diodes, like maybe here and this L2 connection here, are connected to those 2 pads. So I'm going to look at the schematics, and I'm going to use a multimeter to see if this connection is here and this connection is here. I will use those pads to put the cap, just so I don't have to mess with this, right? So I've scratched it all up and everything, but I haven't created a short. I'm just trying to get rid of all of the corrosion that's on it, to clean it up a little bit. All right, just trying to get all the nastiness off of it. And I may try putting a little bit of solder on it just to see if it makes the pad obvious, where it'll take the cap. This one is also a 33, but it's on a different line, so it doesn't look as bad, but I'll probably replace it too. But I had to do these 2 this first go around just because they're falling off the board. So we'll do those and see if it fixes our problem. If it does, I'll still replace these other ones. But they should be easier because they don't have as much damage. Alright, so I'm going to show you my ugly repair. Now keep in mind, we're dealing with non-perfect situation here. I can't get to the other side of the board. So there's my one that I added. According to the schematics, that's exactly where it needs to be. Okay, I'm worried about that Zener diode. Might have to replace it, but if we do, like I said, you can throw it right across this cap. It'll be easy. I just don't have that diode. I'd have to order it. Now here's the other one. Ugly, ugly, ugly. And I was going to put it on different traces, but whenever I thought about that, I would have to have it all stretched around here because it goes all the way from here to here. So I just very carefully made a little puddle of solder on each one of the traces there, and then soldered the cap to it. Now, after I did that, I checked to make sure that the two legs were not connected to each other, proving that the two pads aren't connected. And then I checked that each leg wasn't connected to ground, which is what wraps around it there. And then I checked to make sure that that leg had continuity to that left pad of L2 there, and then the top leg had continuity to the banded side of D4 there. And everything seems to be cool. It seems right. So we're going to try it just like this and not worry about this one or these four yet. We'll come back and do those, but I'm just curious if that's going to fix our problem or if we're just barking up the wrong tree the whole time. Well, that seems to have fixed it. It's steady as a rock now. Sega! Very cool. All right, so if you run into that problem, look at the capacitors on the back of the actual display, and you can't remove that board. You have to do it from the top. It is a really cool looking display that it's that big. Let me turn off the lights so maybe you can see it a little better. Very cool. Alright, so our display is back. I didn't know that we were going to get it for sure, but it was kind of obvious once you started looking at it. Look how it can display the smaller text just perfect now. So yeah, if yours is doing the exact same thing with the rows jumping, check out those caps. If you've got a problem with the columns, it might be the other caps. But you know, really what it comes down to is all of those need to be replaced. But you got to be careful since you got to do it from the top. So that's cool. I was happy to pull that off. So leave your comments down below. Let us know what you think. We will be back here in a couple days. Well, we'll keep working through it. We got to work on everything else in the game, and we have to put the playfield back together. We have all the parts. We just don't know. Well, we think we've got all the parts. We've got all the parts that were given to us with the game. So hopefully everything's there. But that's a cool little fix on the display. So give us a thumbs up for taking the trouble to film it, and leave your comments below, and we will see you on the next one. Now, by the way, if you like these 90s model DMD games, we work on them every once in a while. I'll put a video of one of them that we did just recently up here so you can check it out. We'll see you back here in a couple days.